The next technique is called as the Huffman coding. So this is actually one of the compact possible code wherein you get the number of or the length of the code as minimum as possible. Okay, so the length of uh, whatever code we get, it will be in the most minimum format, minimum length. Okay, all right. So okay, so okay, let me give the steps. So first, we'll follow the steps, and then we will be right. Okay, so this is the procedure. Okay, we'll solve a problem, and meanwhile we'll look at the procedure. I think that should be easier. Okay, right. Okay, so let us say there will be a set of symbols given. Okay, symbols could be S1, S2, S3, and S4 mostly. Okay, and the probabilities will also be given, right? Maybe 0 0.4, 0 0.3, 0 0.2, 0 0.1. So the default condition is that you will write it in the descending order only, always. Okay, if it is not given, you need to convert this into the format which assigns the descending order to that, right? Okay, so start with the source symbol. I can write it as capital S, write whatever symbols given over there, S1, S2, S3, S4 in this case. Yes. Okay. Right. Then we have the probabilities given. So pi, this is important, 0 0.4, 0 0.3, 0 0.2, and 0 0.1. Okay. So what we do, we write one column space free for the what is called as a code. We'll fill this later. Okay. In the Huffman coding, just remember the S, right, followed by S in the sense the source, then the probability, then the code. Okay, right. Now you see you have once again the probability pi coming into picture, and you leave another space empty, that is code. So this will repeat. How many times it will repeat, we'll see. Okay, right. Now, so the idea is that, right, this the empty column for code, anyway, you have to leave it, right? Then to fill the next pi column below the pi, what I should do, I should add the last two probabilities. Okay, so the last two probabilities you add, how much you get? 0 0.2 plus 0 0.1, that is 0 0.3, right? We'll follow one convention throughout the problem. Okay, the convention is that either you replace the new value, like you see 0.2 plus 0.1, I get a 0.3, right? Either you replace that to the highest position possible, that means 0 0.4, then I'll write a 0 0.3, which is because of this addition. Okay, I'm placing that at the highest position. If there is a already existing 0 0.3, it will come down. This is one convention. Okay, always if at when while adding I get an answer and that answer is equal to something which is already there, right, then the newly added answer will go to the top. Okay, this is one particular type of what you call convention. If you follow this, absolutely fine, follow the same thing throughout. Okay, don't change this in the middle. Okay, what should be the other one? Other one will be also very similar, right? You see, whenever I add the two numbers and I get the probability such as 0.3, which is already existing, I will put it at the lowest possible position. Like 0.3, which is there, I'll keep it 0.3 only. The new value 0.3, right? The new value 0.3 will go to the particular position that is below this, right? So this is also fine for us. Okay, so just see what you are going to do, you decide, and you can stick to the same thing throughout. Okay, this is what is the condition. Okay, anyway, so since we have written this already, I'll stick with this for the right time being. All right, so anything you want, you can follow. Okay, so there is nothing wrong in writing the other technique as well. All right, so all right, let me follow this technique itself. So I have the 0.3 coming here, and I also have a 0.3 over there. Okay, so you can see that the 0.3 and the 0.3 is done. Now you need to follow the procedure once again. Add the lowest three values. Is it okay? So, right, last two values, 0.3 plus 0.3, 0.6. So now I don't have any other option. I'll go to another PI where I'm going to write, I'll write like this. So this is how much? The 0.6 should come here, and the 0.4, which is already there, comes down. Correct? 0.6 is 0.4. Right? So this is the one which comes down like this, and this is the one which goes there. You can actually keep tracking them as required. Okay. So because of that, we are writing in this fashion. So 0 point, just a second, it's not taking my entries. Okay, so the S is given 8 different symbols, and 8 probabilities are also given. So we need to calculate the Huffman coding for this, and also find the efficiency of the code. All right, tell me the code. So it will be in a different order, I guess. Okay, according to your order, tell me the answer. It's for A, right? Yeah, you should write it in the descending order, right? So A will be first one, correct? That's okay, right? 0.22. Yeah, for correct. For A, what is the code? I didn't write. 10. All right. Then you have H, I guess, right? Okay. For H, it is 1 1. Okay. Then, all right. So that is B. Okay. All right. Okay. All right. All right. Okay. 1110. Is it? This is 1110. And which is the last symbol? E, right? Okay. 0 followed by 4 ones. Correct? Okay. Now calculate the h of s, calculate the length and efficiency. H of s is equal to 2.75. So L equals to 2.8. So the efficiency becomes a 98.2%, right? Similarly, we can calculate the redundancy as 1.8, I guess, right? Okay. Okay, all right, fine. So like that we can calculate. Now there is a variety possible here that is called as a ternary or a quaternary code. All right. So this is ternary Huff. So the ternary code uses three symbols. Like previously it was a binary like zeros and ones, right? Now the ternary code uses 0, 1, and 2 as the set of symbols that can be used to generate the codes, right? It can be extended further if required. You can go for a quaternary, etc. All right. So there is a small difference between the binary and the ternary, quaternary, etc. In ternary and quaternary, or the higher order in which we try to write the codings, right? There is a difference. The difference is you just have to remember the one equation. Okay, the equation is given by n is equal to, this is small letter n is equal to capital N minus the r divided by r minus 1. This should be an integer. Okay, right? I have to make sure that, right, this number becomes an integer, right? That's what I need to check. So here, this number, right, is expected to be an integer, right? Where capital N is the number of symbols, okay, or number of message symbols. It's not the symbols used to generate, okay? So this is number of source symbols. So R becomes the base, right? So that means this is 3 for ternary, okay? And this value becomes equal to 4 for quaternary, right? Quaternary uses 0, 1, 2, 3, etc. Right? Like this, we have to do the calculation. Okay. Now, let us solve a problem. Let's start with the problem. Then we'll see how we can apply. I'll show you the application of this formula as well, right? Okay, let's start with the problem, right? So let's say the source given. So the source given is like this: A, B, C, D, E, F, G, H. Okay, that is S. Then we have PI, the probabilities are given. So 0 0.22, 0 0.2, 0 0.18, 0 0.15, 0 0.1, 0 0.08, 0 0.05, and 0 0.02. Okay, this is given. Now you see what is the number of symbols present. Capital N is equal to 8, right? There are 8 symbols: A, B, C, D, E, F, G, H, and I want to use a ternary code, so R equal to 3. So first calculate N. N is equal to capital N minus R divided by R minus 1. All right, so N, how much? N is equal to 8. 8 minus 3 divided by 3 minus 2, 3 minus 1, so that is equal to, so this is 5 by 2. You see, this is not integer, correct? So this is not going to work, right? I have to change N. N cannot be decreased, N can be increased, right? So check with N, capital N equal to 9 means what? So this is 9 minus 3 divided by 2. So 9 minus 3 is 6, 6 by 2, so that is equal to 3. So this is an integer. That means I need 9 symbols in this particular problem. Okay, so you cannot do with 8, you have to go with 9. So add a ninth symbol, h, after h you add I, okay, and make the probability 0, because that does not exist, right? There is no probability associated with that, right? I'll just do this. Is it okay? Then after this everything remains same, right? What I do, I'll write the code, right? I leave it blank, I go for a pi once again, right, wherein I'll add the last 3, not 2 now, because ternary, right? Add the 3, right? Yeah, every time you add 3 3 now, because it is a ternary 3 3 case. Ternary is 3, so 3, right? Quaternary is 4, that's all, right? Oh, huh. So what happens now when I add them together? I get 0 0.7. So I will write all the others as it is: 0 0.22, 0 0.2, 0 0.18, 0 0.15, 0 0.1, 0 0.08, and this is 0 0.07. Correct? Add these three. So what you get? 0 0.25, right? Okay, so that means I'll write a code here followed by another pi where this will come to this location 0 0.25. Then write the others 0 0.22, 0 0.2, 0 0.18, 0 0.15. Add these three. So you have code followed by pi. How much do you get when you add? I think 2, 3, 4, 53. So 0 0.53, right? Below that, I'll write a 0 0.25 and 0 0.22, right? You don't have to add because last column has only 3. Okay, now start with the coding part. Now you see the coding will be either you add 0, 1 and 2, or you will write 2, 1, 0 as per your requirement, right? Whatever you do, you follow the same thing. So I'll write 0, 1, 2. Is it okay? So from where I got 0 0.53, that actually came from this, right? From here. So these three will get, according to my convention, I'll get 0, 0, 0. But it should not be same. So it will be 0, 1, 2. Remaining terms will be like this. This is coming from here. This is coming from here. So this will have 1 and 2. Right, now I can see that this 0 0.25 came from the last set. So for that reason, what I'm going to do now, that is, okay. So this will be 1, 1, 1, but you add 0, 1, 2. So remaining terms will be carried away in the same fashion. So this is going to be 2. This is 0, 0, 0, 1, 0, 2. Is it okay? So this 7 comes from the previous case. So remaining terms you can carry as it. This is 2, 0, 0, 0, 1, 0, 2. This is 1, 0. 8 comes because of 1, 1. And this is 1, 2, 1, 2, 1, 2. Start with the 0, 1, 2. Out of which this you need to discard. Okay, this will be discarded. Only till h, because I is what I added, correct? It's not there. So because of that, you will cancel that particular row itself. Okay, once you do this, you know the lengths now, LIs are known to you. You obtain that from the third column, that is a code column. Then you calculate the required terms, that is, you find the, I need to find efficiency. Before that, I need h of s and the L. Okay, please calculate. No, if that, for that reason, see, if you had, while calculating the h of s, you should not take base 2 in that case. Simply take normal log. Okay. Now it is not normal log, right? You already have considered log to the base 2 in h of s. So I should cancel that log to the base 2 by dividing by log to the base 2 of 3. So when I write log to the base 2 of 3, answer gets converted into log to the base 3. Okay, yes. Now you will get the answer. Okay, give me h of s, then we'll do the calculation. 94%. So what is h of s? Okay, this is 1.7. So yes, 1.7 by 1.85 is approximately 94%, right? Okay, so that is the required answer for this kind of.